Good morning dear students and welcome back to this new video of mole concept. Here in this video we are going to discuss some applications of Avogadro's law. Already you know that what is Avogadro's law. Avogadro's law, according to the law, it states that equal volume of different gases at the same temperature and pressure have the same number of molecules. That means, for example, see here hydrogen, chlorine, when react with each other, they produce that what? Hydrogen chloride. See here, when one volume of hydrogen react with one volume of chlorine, it produce what? Two volume of hydrogen chloride. So that means what you find out? That means this hypothesis, what is based on? That means an equal volume of different gases under similar conditions of temperature, they contain the same number of molecules. So let's discuss what are the applications of Avogadro's law. Here you can find out, see what are the applications of Avogadro's law. That means it explains the Gay-Lussac law. It determines the atomicity of the gases. It determines the molecular formula of a gas. It determines the relationship between molecular mass and vapor density. And it gives the relationship between the gram molecular mass and gram molar volume. These are the application of what? Avogadro's law. But according to your syllabus, you have only to discuss now that is to determine the relationship between molecular mass and vapor density. And the formula is that to molecular mass, okay, molecular mass equal to 2 into vapor density. Okay, so how can you find out that molecular mass equal to 2 into vapor density? So first we discuss that what is that molecular mass. That means relative molecular mass. See here, the relative molecular mass, that means it is defined as the ratio of the mass of one molecule of the gas or vapor to the mass of one atom of hydrogen. What it states that? It states that means the relative molecular mass. The relative molecular mass is defined as the ratio of mass of one molecule of the gas. That means any gas, okay? Any gas or vapor to the mass of one atom of hydrogen. So according to the formula, that means the formula of relative molecular mass is equal to mass of one molecule of the gas or vapor divided by mass of one atom of hydrogen. Understood? That means any one molecule of any gas divided by mass of one atom of hydrogen, you have to find that relative molecular mass of the gas. So what is vapor density? Now I have discussed that what? Molecular mass is equal to 2 into vapor density. Now you got that what is molecular mass? Relative molecular mass. Okay. Then now I have discussed that what is vapor density. Vapor density, that means it is defined as that vapor density is equal to, that means the ratio between the mass of equal volume of the gas or vapor and hydrogen under the same conditions of temperature and pressure. This is the definition of vapor density. Okay. So let's see here. Vapor density, it is defined as the ratio of the mass of a certain volume of the gas or vapor on the mass of the same volume of hydrogen at the same temperature and pressure. Already you know that vapor density. Density is equal to what you know? Mass per volume. Okay. You know that density is equal to mass per volume. So vapor density. Now you have to find out what? What is vapor density? What is the definition? Definition. Vapor density is defined as the ratio of the mass of a certain volume of the gas to the mass of a same volume of hydrogen. Okay. At the same temperature. That means standard temperature and pressure. So according to that formula, vapor density is equal to what? Density of any gas by density of hydrogen gas. According to the formula of vapor density. Okay. But you know that what is density? Density is equal to what? Mass per volume. Understood? See, we have to find out that what is vapor density. Okay. So density of vapor density is equal to density of any gas divided by density of hydrogen gas. So now density is equal to what? Mass per volume. So you can write now mass of a certain volume of any gas at standard temperature pressure divided by mass of the same volume of hydrogen gas at standard temperature and pressure according to the law vapor density. Okay. So volume will be C. In both the cases what? Volume remaining same. So if you cancel it, what you will be get? Vapor density is equal to mass of n molecule according to the Avogadro's law. Okay. Mass of n molecule of standard temperature and pressure divided by mass of n molecule of that molecule of hydrogen gas at standard temperature and pressure. Okay. So now what you will get? Vapor density. Vapor density is equal to what? Mass of one molecule of the gas divided by mass of one molecule of hydrogen gas at standard temperature and pressure. Why will we get 1? Because instead of n, if you are taking 1. So what is the formula now you get? Now vapor density is equal to mass of one molecule of the gas divided by mass of one molecule of hydrogen gas. As we know that hydrogen gas is a diatomic. So now value is what? How much you will get? Mass of one molecule of hydrogen, that equal to 2. And what is the form? What you will be get? That mass of one molecule of any gas at standard temperature pressure. That means what? Molecular mass. So now vapor density, what you will get? Molecular mass divided by 2. Okay. See, vapor density is equal to molecular mass divided by 2. That means 2 into vapor density is equal to molecular mass. Got it? That means what is the formula? Now you remember that 2 into vapor density, that is equal to relative molecular mass of any gas. Okay? That means molecular mass of any gas is equal to 2 into vapor density. So 2 into vapor density is equal to molecular weight. And the relative molecular mass of a gas or vapor is twice of its vapor density. So now will we get that formula? That means 2 into vapor density. Okay, 2 into relative vapor density is equal to that relative molecular mass of gas or vapor. So this explanation also not needed for according to your syllabus. Only you remember that what is the formula. That means relative molecular mass equal to 2 into vapor density. This formula you remember, and on the basis of this formula, okay, that means molecular mass, you have to practice some questions. So let's see here one example. See here, that is calculate the vapor density and molecular mass of carbon dioxide if 200 milliliter of the gas at standard temperature pressure weighs of 0.40 gram. Remember that question? You have find out what is vapor density. Okay, already you know that vapor density is equal to what? That means 2 into vapor density is equal to molecular mass. Now you have to find out vapor density. Vapor density is equal to what? Molecular mass divided by 2. Okay, so here you find out, see. Now here how much is given? 200 milliliter. Okay, 200 milliliter of carbon dioxide at standard temperature, that is how much weight? 0.40 gram. So 1 liter equal to, you have to get how much? And 1 liter of carbon dioxide at standard temperature pressure will weight equal to 0.40 into 1000 divided by 200. Why is it 1000? Because 1 liter is equal to, here is given what? 200 milliliter. So you convert it, that equal to 1000 milliliter. That means 0.40 into 1000 divided by 200, that equal to 2 gram. So according to the formula vapor density, now we have to find out what? Weight of the molecular mass of carbon dioxide at standard temperature pressure divided by weight of 1000 milliliter of hydrogen at standard temperature and pressure. So already you got that what is the weight of 1000 milliliter of 1 liter equal to how much? 1000 milliliter. Already you find that is 1000 milliliter of carbon dioxide at standard temperature or pressure equal to how much? 2 gram. So 2 divided by how much? That is, here is in the question it is given, see, atomic weight of hydrogen 0.09 gram. So 2 by 0.09 gram, that equal to 22.22. Okay. So molecular mass is equal to what formula? 2 into vapor density. Okay. So now 2 into vapor density what you got? 22.22, that equal to 44.44 gram. So this is the molecular mass of that gas. So like this we'll have find out one more simple questions. How will you find out that vapor density? See here, choose the correct answer from that options. the vapor density of carbon dioxide is given. Okay, the vapor density of carbon dioxide, you have to find out what is the vapor density of a carbon dioxide. Okay, then you find out what is the molecular mass. Molecular mass of carbon equal to how much? 12, and oxygen is given 16. So the total molecular weight equal to how much? 12 plus 16 into 2, because CO2, that is 32. 32 plus 12, that equal to 44. Okay, so formula, according to the formula, what? Vapor density is equal to molecular mass by 2. So 44 by 2 equal to 2. So it is got answer 44 by 2 equal to 22. So that answer is 22. Okay, so this is that only in your syllabus. Now you have to find out that application, only one application, that is the relationship between the molecular mass and vapor density. So based on this topic, you have to practice that all the numericals. Thank you.